The Aeolus satellite embarks on a fiery descent towards Earth. On Friday, the final instructions were transmitted to the Aeolus satellite in Europe, directing it to descend from its orbit in the atmosphere. Over Antarctica, the space laser that was specifically engineered for the purpose of mapping Earth's winds made its re-entry into the atmosphere. If any remnants managed to endure the blazing descent, they would have safely landed far from any danger. Weather forecasters celebrated the triumph of the British-made spacecraft's mission as it yielded unprecedented data that could be used to predict weather patterns several days in advance. Aeolus was widely seen as a groundbreaking force. Using an ultraviolet laser, air movement was meticulously monitored in various global locations, spanning all altitudes. The triumph of the mission has prompted the initiation of preparations for future replacements. The Aeolus project almost didn't come to fruition due to the challenges associated with its implementation. For more than 10 years, engineers faced numerous challenges in their quest to create a device capable of functioning effectively within the vacuum of outer space. Aeolus earned the nickname the Impossible Satellite due to the delay. The team of engineers, headed by the European Space Agency, ESA, persevered in their efforts due to the ultimate reward of obtaining the inaugural comprehensive perspective on the atmospheric movements of Earth. This groundbreaking insight encompasses the entirety of the globe, spanning from the Earth's surface to the upper stratosphere, covering a range of 0 kilometers to 30 kilometers in altitude. Nevertheless, during the period from 2018, when Aeolus began its journey to the launch pad, to the completion of its nearly 5-year mission, the recommended procedure for safely removing out-of-service satellites from orbit had undergone significant revisions. In order to ensure their safe return to Earth, astronauts must possess the capability to precisely determine the location where they will re-enter the atmosphere. Alternatively, they must have the assurance that they will completely burn up upon re-entry without leaving any remnants behind. Unfortunately, Aeolus did not meet the specified requirements. The propulsion system of the satellite lacked the necessary strength to precisely control its descent trajectory. Additionally, it was projected that approximately 20% of its equipment, such as the graphite telescope and fuel tanks, would survive the re-entry and reach the Earth's surface. Instead of opting for a traditional re-entry, the ESA flight controllers utilized an assisted re-entry technique. Over the course of the past week, they directed the satellite to gradually decrease its altitude through a sequence of maneuver. The final maneuver, executed on Friday, brought the satellite to an approximate elevation of 120 kilometers. The subsequent outcome was the anticipation that the gravitational forces of the atmosphere would lead to the satellite's descent and eventual destruction after approximately 2.5 revolutions around the planet. At approximately 7 p.m. GMT, sensors that are accessible to US Space Command validated the occurrence of Aeolus's concluding moments, which took place above the Antarctic continent. The groundbreaking observations made by Aeolus were invaluable in generating medium-range weather predictions. Specifically, it monitored the movements of winds that would influence upcoming weather conditions in the days to come. The research undertaken contributed to a deeper understanding of hurricanes and the dispersion patterns of volcanic ash in the upper atmosphere. Prior to the advent of Aeolus, a variety of methods were used to gather wind profiles. These methods included the utilization of spinning anemometers, balloons, and aircraft, as well as the observation of cloud movement in the atmosphere and the analysis of oceanic turbulence. However, these methods only provide limited insights into localized events and specific altitudes. This is precisely why the broader view offered by Aeolus was held in such high regard. The member states of the European Space Agency, ESA, have already given their approval for a budget of €413 million or 353 million Great British pounds to initiate the development of 2 subsequent spacecraft called Aeolus 2, which is fittingly named. Europe's meteorological satellites are managed by EUMETSAT, an intergovernmental organization that will also provide a substantial financial contribution of nearly €900 million. Towards the conclusion of this decade, the initial of these subsequent missions is anticipated to commence. Due to the considerable €71 million contribution from the UK's ESA and its significant subscription, 16%, to EUMETSAT, it is highly likely that the British division of aerospace manufacturer Airbus will once again take the lead in producing the spacecraft. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.